So this is 2023 ADDMA Paper 1, question 10 on vectors. So part A is saying the position vectors of points P and Q relative to the origin O are 4i plus 2j and ki plus 4j respectively. Given that QP is perpendicular to OP, find the value of K. So if QP is perpendicular, we usually use this symbol, to OP, then their dot product must be equal to 0. So this means QP dot OP must be equal to 0. So all we need to do is find QP and multiply them, then equate the product to 0. So our QP is given by, okay, I'll write it like this: OP minus OQ. It's just the same as the way you normally write it. Maybe I should just use the language I used to. So this is like QO plus OP. So our QO will be the negative value of OQ. So our OQ, our P and Q relative to the origin. So this is our P and this is our Q. So we have negative Ki plus 4j, then plus our OP is this one here. Remember, this is our P. And then we can simplify it. So this will be like this. And then we can put the j terms together and the k terms together. So the I terms will be 4 minus k. Then I'll factor the I out like this. And then the j terms, this minus negative 4j plus 2j, this one will be negative 2j. So this is what we have as our QP. And then our OP is 4i plus 2j. So we can just multiply these two and equate the product to 0. So we can say 4 minus k I minus 2j multiplied by 4i plus 2j, and this product must be equal to 0. So to multiply vectors, remember that you multiply the I components alone and the j components alone. You don't need to multiply the I by the j's and the j's by the i's, because those things will give you 0. Remember, I is perpendicular to j, so when you multiply them, you just get a 0. So this times this will give us 4 times this. Remember that I squared is just a 1, because this is like multiplying 1 by 1. And then minus 2j multiplied by 2j, negative 2j multiplied by 2j, this will be 4. Remember, j squared is equal to 1. Yes, so now we can solve for k. So I can just take this one to the, or maybe we can just expand. This is 16 minus 4k minus 4 is equal to 0. Then 16 minus 4 is 12. and then we can take the 4k to the other side, and our k will be equal to 3 when you divide both sides by 4. And then part B, two lines R1 and R2 intersect at R, and then R passes through the points with position vectors this and that. Given that R2 is equal to I minus 3j plus lambda I plus 2j, find the coordinates of R. So in this case, this is like coordinate geometry, where you have been given one equation, and then instead of being given the other equation, you've been given 2 points through which it passes. So in this case, you can find the equation of the line where these 2 points are lying. And then once you find that equation, you can solve it simultaneously with this. So I just thought I should give you a quick roadmap of where we are going before I actually find the equation. So you can just say, let these 2 points like be, this one will be 5i plus 3j, and then this one be the position vector. Actually, these are position vectors of 2i minus 4j. So now we can find the direction vector. Remember, to find the equation of this, you need the direction and one of the 2 points. One of the points or any of the points which lies on that line. So to find that line, let's start by finding the direction vector, the vector in the direction of AB. So this one will be AO plus OB. So AO is like the negative version of OA, 5i plus 3j. Then OB is negative 2i minus 4j. So this one will be negative 5i. I'll put it together with 2i. Then this is also negative 3j together with 4j. And then this and this will give us negative 7i. And then this will also give us negative 7j. So this is the direction vector. You can even simplify it by factoring the negative 7 out, and then you just get your direction as I plus j. So whether you get it like this or like this, it's still the same thing. So I'll use this one instead. Even if you use this, you still get the same answer. So now, so 2 lines. We are trying to find the first equation. So the first equation, R1, will be, I'll get one of the 2 points. I think I'll go for this one to minimize the negative signs as much as possible. And then plus, you can use another letter. Since lambda has been used, let's use this one. Some people call it mu, others mu, but the Greek version of it is mi. This is letter M in Greek. So this is our second equation. All we need to do is solve the 2 equations simultaneously. So our R1, our R2 is this one here. We've been given. So we have I minus 3j plus lambda I plus 2j. And then we have to solve these 2 equations simultaneously. and then find the value of lambda and the value of me. So once you find the value of any of these two, then you would have found the meeting point of the two equations. So if we have a common point here, that means our R1 must be equal to R2. So I can equate this to this. So 5i plus 3j plus me plus I plus j, this must be equal to this one. Remember that point should satisfy both equations because it is found on the meeting point of the two equations. So I can just rearrange the left hand side and the right hand side in such a way that I have the I components this side and the j components this side. So we have 5i, we expand that, we have me I plus 3j, we expand this will be me j. So I've expanded this and rearranged so that we have the I components here and the j components this side, and then I have the I there, the other I is there. I can just multiply the lambda by I, so this will be lambda I. Then I can get the 3j, negative 3j, and add the 2 lambda j. And then at this point, I can factor the i's and the j's. So this one will be 5 plus me I, and then this one will be 3 plus me j when you factor the j out. Then this one will be 1 plus lambda I, and then this one will be, I'll write it as a negative 3, 2 lambda, and then j. So now to find the values of lambda and me, all you need to do is equate the coefficients of i's and the coefficients of j. So we can say 5 plus me is equal to this. Since these two are equal, then the coefficients of the i's and the coefficients of the j's must also be equal. So we have 3 plus, I'm getting the j terms now, this is equal to negative 3 plus 2 lambda. So we can simplify by taking these things to the other side. By the way, this is my equation 1, and this is my equation 2. Or we can simply subtract so that we eliminate the me. So this minus this will be 2, this minus this is a 0, then 1 minus negative 3, this will be a 4, then lambda minus 2 lambda, this would be negative lambda. So I can just take the negative lambda this side, then I remain with a 4, bring the 2 this side, so that my lambda is equal to 2. And then I can also solve for my mu, but this should be enough. So I'll use the first equation. 5 plus mu is equal to this. So you can have 5 plus me is equal to 1 plus 2. So this is a 3. So this is a 3. You take the 5 to the other side, you have negative 2. So now to find the coordinates of the meeting point, I can either use the first equation or the second equation. So we know that using the first equation, R1 is equal to 5i plus 3j plus our me is -2, and then I plus j. When you simplify this, you have 5i plus 3j -2i -2j, and then you can subtract 5i minus 2j, this will be 3i, 3j minus 2j, this will be a j. So this is the point you are looking for. I think that's the R, the meeting point. And then if you want to use this, the answer will still be the same. So our lambda here is 2, so you can have this, then lambda is 2i plus 2j, and then you have this times this is 2i, and then minus 3j, this times that will be 4j, and then this and this will give us 3i, then this and that will give us a j. So whether you use this or that, the answer will still be the same. So this is the vector, the coordinates. So actually the question is asking you to find the coordinates of R, which is the meeting point over the two vectors. So the coordinates will be 3, 1, and you are done.